Hello everyone, in this video let's start with our series Roadmap to Become Competitive Programmer 5 star. So we are solving fifth problem which is Mahasena. Sorry, sixth problem which is Mahasena. So the problem says Katappa, as all you know, was one of the greatest warrior of his time. Yeah, we know this from Bahubali movie. So yeah, the kingdom of Mahismati had never lost a battle under him as armed chief. Okay, and the reason for that was the really powerful army, also known as Mahasena. Katappa was known to be very superstitious person. He believed that a soldier is lucky if the soldier is holding an even number of weapons, and unlucky otherwise. Uh, he considered the army as ready for battle if the count of lucky soldiers is strictly greater than count of unlucky soldiers, and not ready otherwise. Okay, so basically what they're saying is they have a soldiers, and soldier is holding some number of weapons. If the soldier is holding even number of weapons, uh, then they are lucky and they are probably to be win. And if the number of lucky soldiers are strictly greater than number of unlucky soldiers, then they'll definitely ready for the battle. Else they are not ready for the battle. So, given the number of weapons each soldier is holding, your task is to determine whether the army formed by all these soldiers is ready for battle or not. Okay, we all know if there is no reminder when divided by to any number, then that is even number. So, input format is saying first line of input consists of a single integer and denoting the number of soldiers. So, let us take n int n, which is number of soldiers. The second line input consists of n space separated a1, a2, an, where a of I denotes the number of weapons that the ith soldier is holding. Yeah, we'll look into this. And output will have to generate ready for battle if number of soldiers, number of lucky soldiers are greater than number of unlucky soldiers. So let's take first example. Here n is 1 and we have only one soldier, and one soldier is holding one weapon, and one weapon means it is odd, so number of unlucky soldier is 1 here, and number of odd I mean lucky soldiers is 0. So 0 greater than 1 is false, which means they are not ready. And if you see here 1 n is 1 and one soldier is having two weapons, which is even, so even count is 1 here but odd count is 0. So in the question they have said if even count is strictly greater than odd count, then they are ready for the battle. So which is the case here. And now if you see here there are four soldiers. First soldier is having odd number of weapons, second even, third odd, fourth even. So if you see even and odd count, both are same in this case, but question they're asking even count has to be strictly greater than odd count. So 2 and 2 are equal, so they're not ready. And if you see this example, there are three soldiers. Two soldiers are having even number, one soldier is having odd number. So yeah, 2 which is strictly greater than 1, so they are ready for the battle. And let's see the last example. There are 5 soldiers, and 2 soldiers are having even number, 3 soldiers are having odd numbers. Okay, so 3 greater than 2, which means odd number is greater than even, so in that case also they are not ready. So I think pretty much you got the problem statement. Let's try to the code. So what we'll do is we'll take two variables, even count, which will be initialized to 0, and then odd count, which also will be initialized to 0. And we'll take one more count variable, just a variable. So we'll run through a loop till n. Okay, because there are n soldiers, so we will take one by one the soldier holding number of weapons in count variable, and we'll see here if count modulo 2, which means remainder is 1, which is odd basically, so we'll increase here odd count plus plus, else remainder is 0. In that case even count will be increased, like even number of soldier, lucky soldier will be increased. And outside this for loop, once we have number of soldiers having number of soldiers are lucky and unlucky. So we need to check here if even count is strictly greater than odd count. If it is, then we need to return this thing, ready for battle. Let's copy paste. Okay, now if even count is less than or equal to odd count, then it will go in else condition. So in this case we need to return not ready. So let's try to run the code. So for this case it is not ready, so we have got not ready. Let's try to submit the code. Yeah, it got submitted. So I think you got the problem statement. So it was easy, kind of uh, in a given array elements, or you can say in a given n numbers, we need to find number of even numbers and number of odd numbers. And if number of even numbers is strictly greater than number of odd numbers, that in that case soldiers are ready for battle, or else they're not ready. So yeah, thank you guys. And if you analyze the time complexity, it is just O of n and space is O of 1. Yeah, thank you.